you so much, Padma, for that nice introduction, as well as thank you to the AOQR for inviting me to this particular lecture. Thank you, all of you. I'm going to share the slides now with trying to give a kind of a overall view as well as some of the activities that we do it. So I will rather stick to very just expecting there are potentially some young researchers out there, as well as people who are not very well aware about some of the polar activities. So as you can see that we are from the National Center for Polar and Ocean Research, which is truly an Indian gateway to the polar regions, because all the activities which happens in Antarctic, Arctic, in Southern Ocean originates from this particular place, because this is what the nodal agency for that. And we are under the the Ministry of Earth Sciences, which is again a truly unique ministry in the whole globe for the Earth system sciences. So as you can see that we are mostly are situated in the hemisphere where actually we are more worried about actually the heat and the dryness rather than about the cold and the ice. However, there is also the places which are actually the very large part of the Earth's surface is also covered with ice or frozen ground or the sea ice, altogether what we call as the cryosphere, where the water is found in frozen form. And we have this Antarctica in the southern hemisphere as truly a continent of the size of US and India together, covered with more than 98% ice, and a continent which also doubles to its area during the winter time because of the sea ice expansion, and around which there is an ocean which connects the all major oceans like Atlantic, Pacific and Indian Ocean. We call them as Southern Ocean. Then you have in the north what is originally found actually as an Arctic, which is mostly sea ice. That is nothing but the sea water frozen. And then there are some islands like Greenland, Svalbard, and some parts of the continents like the high Arctic, Canadian high Arctic, Alaska, or the Siberia, or the high Arctic of the Russia, and some of the Scandinavian countries, Iceland, and so on. So essentially, the northern hemisphere is what you call land hemisphere, whereas the southern hemisphere is a water hemisphere. We have the large continent is Antarctica over there. And if you look at let me also have a pointer option in between. Okay, so if you look at around land, which is the place we call actually as Himalaya, and its surrounding regions like this, the Tibetan Plateau and rest of the world where the water is found in frozen form, we call as the permafrost. Altogether, there is also a terminology people call many times as third pole, which is of course actually is a kind of a controversial term by itself. But however, it has popularized the concept of the idea about actually how much they actually contribute to our life and future. Because this is an area where actually most of the the major 10 rivers in the world originate, where again contribute to the most of the nearly kind of a billion people actually are depending on directly or indirectly on its water and its associated activities. And as being the area mostly highly populated in the whole globe, it is going to affect in future as the climate is changing. Why are the polar regions so important? The single most important, I would say actually, that what it related to the grandest challenge the humanity faces now, which is the climate change. And the polar regions, both Antarctic and Arctic, and even the third pole, essentially control a major global tipping points. Global tipping points are those the thresholds beyond which we don't expect the climate to come back to the normal. There are many such tipping points in the northern hemisphere, southern hemisphere, as well as in the tropics, including the kind of the Greenland ice sheet complete melting. It's an important tipping point actually, which will impact the Atlantic meridional overturning circulations and so on. Then you have this, the West Antarctic ice sheet, the loss, can be a global tipping point because it will again impact the entire circulation patterns and so on. And most of the polar systems actually modulate those, I call them actually as a pacemakers of the global climate system, including what happens in the tropics. It's also happened to be one of the most vulnerable parts of planet Earth in a warming world. And if you look at the current the availability of fresh water on this globe, nearly 70% of global fresh water is locked as ice, mostly in Antarctica and some as glaciers. And the melting of this particular polar ice is going to be one of the most critical factor in future sea level rise, other than the thermal expansion, which is already reached to a very critical level. And the next stage, what's going to increase is going to be the most important is actually the increasing contribution from the Antarctic and the Greenland fresh water towards sea level rise. And also, you should also remember actually this, although we do keep saying that actually that the Antarctic ice is going to be the most important critical factor in sea level, there's also huge uncertainty how much we know about it. The current estimate shows that the actual estimate is based on various available satellite modeling and the in situ data and so on. Nearly 50% of error is involved in that particular numbers. So can you imagine actually having at 50% of uncertainty what we are going to predict in future? That's going to be hugely different than what we currently know it. So the simple reason is actually that because there is hardly any data even after several decades, due to the simple fact that it's a continent size of about nearly 4 to 5 times of Indian subcontinent. Having even about 100 places measuring in such a continent of that size is not going to be really sufficient. And then there are a lot of other uncertainties actually below after all, Antarctica is covered mostly by ice. And at the bottom of this ice, which is in contact with the land, also has it reached a level where it's a melting point of ice because of the high, the weight and the pressure related pressure melting is happening over there. So we do not know how during the pressure this kind of melting actually which is happening there, how good is the bottom, which will actually how fast it will allow to this particular ice to start flowing. That's another uncertainty. But all this keeping that apart, economically also it's going to be extremely vital for our future, especially the living and non-living resources in Arctic, because as the Arctic sea ice is retreating dramatically, and we expect it to completely melt by during summertime by 2050 or so. There's going to be opening race for resources. There are plenty of resources which is very well known in Arctic region because of the non-gases and hydrocarbons and the placer deposits and and so on. And several countries have already openly declared that they're going to be mining them. And there's going to be huge impact on that. And also, these regions are very strategically and geopolitically very crucial. As you must have heard in the last couple of months, President Donald Trump has been keep on talking about buying Greenland. He's not just buying Greenland only for its mineral resource or something. It's absolutely not that much big for a country like US. But it's situated in a place, as the globe is melting, it is going to be extremely strategic, important place for military and other security. So every country is trying to get some part of the interest into that area. However, it's also there are going to be a lot of other potential opening of new trade routes, as we call as the Northern Sea route and so on. All this you also need to keep in mind that we expect everything as happens as of now, but as such new routes are also going to be very vulnerable because they're going to be environmentally quite dangerous because these are unknown territories. So as I said, Antarctica, being a remote and frozen continent of extremes, of course, is quite enormous. It's also the coldest place on Earth, where the temperatures are reported about -90 degrees Celsius or so. And it's also happened to be the highest land on Earth, because the average elevation is about 2,500 meters. Due to the simple fact that there's a huge amount of ice sitting over the land, and this ice can be as thick as nearly 4.5 to 4.7 kilometers in certain places. And it's also happened to be very windiest place on Earth, so it's going to be extremely challenging and harsh place to work with. And it is the driest place on Earth, where average precipitation is less than 2 inches per year. And as I mentioned, it's also the iciest place on Earth, because where you can have such a nearly about 4,800 meters of thickness of ice in some places. Of course, that's on the only in some of the East Antarctic. As you get closer to the coast, this ice start to become thinner and thinner and start flowing into the ocean. Compared to this Arctic, as I mentioned, it has mostly many countries are already owning part of Arctic, most of the Arctic, in fact. Wherein Russia has nearly about 50% of this Arctic territory kind of place. And you have this Greenland, you have this Canada, Alaska, Norway, and many of these other Scandinavian countries part of that, and those islands which are having governed by some of this mainland. So Arctic is therefore can also consist of a large, vast ocean where the seasonally varying ice cover, as well as there is multi-ice layers. And also there is a large amount of treeless permafrost in this region. So therefore Arctic, the definition of Arctic itself changes depending on what are you looking at. Simply if you look at the Arctic Circle, which is about 66 degrees north and beyond, further to north, we call them as Arctic Circle. But then there are also other terminology like, depending on the isotherms actually during summertime, depending on the tree lines and so on. So there is no one single Arctic. So this slide tried to give a nutshell what are the most important differences and similarities. As already mentioned, Antarctica is a land, Arctic is mostly ocean, and Arctic has about 4 million residents. That means it has indigenous population. Compared to Antarctica, no one really lives there. Only those people who go for doing research, or those people set up operational activities of the Antarctic stations, or those go as a tourist lives in Antarctica. That's again those short periods, and they come back, keep coming back. So there are no permanent residents in Antarctica. And Arctic is no continent, as I mentioned. It is basically a region covers northernmost parts of 8 countries, and the remaining part is the ocean, which is more, some of them claimed by some of the countries as extended continental shelf, and some of them actually are yet to be claimed, and so on. Whereas Antarctica is no country owns Antarctica. It's a country, continent governed by Antarctic Treaty. Antarctic Treaty happens to be one of the single most, defining treaty in the recent history, which has governed all activities related to a large continent and remained to hold till now, which is one of the finest example of actually how a peaceful activity can be carried out, on this planet, where the current geopolitical and other scenario is so dangerous for the people to really, work. And if you look at the Arctic in terms of summer and winter, they are all on the opposite side, being in the north and south hemisphere. And when you have the summer in north, we have the winter in Antarctica, and so on. And even if you look at the animals and the organisms living there, Arctic is very ubiquitous with the polar bears and some of the Arctic foxes, and very well-known the symbols of Arctic. Then you have this Antarctica, where you have this penguins and seals, and some of these albatross are very symbols of this Antarctic region. So this is what I'm trying to just put them in. Of course, there are various differences, various other factors. It's only just for a general public. I'm just trying to put that. If you look at the Indian activities in Antarctic and Arctic, the Indian Antarctic expeditions started way back in 1981, when the first expeditions to Antarctica took place from Goa. And this is the 45th year actually, which we are continuing with Antarctic expeditions, annual expeditions. Way back in the 80s and 90s till 2000s, actually we used to travel all the way, sail all the way from Goa to Antarctica via Mauritius. But since 2000s actually, that we also shifted our the part of the activities from South Africa, which is one of the major gateway for Antarctica, because the expenses involved in sailing all the way from Goa is enormous, number one. Number two, it's also you spend extra 2 months of time period all the way sailing it. So we have currently actually activities happening from Cape Town, which acts actually our gateway, and we have 2 stations currently operating in Antarctica called Maitri and Bharati, situated nearly about 2,500 kilometers by air or by 3,000 kilometers by ocean, by sailing. And we also had an opportunity to undertake expeditions to South Pole, North Pole, and then of course we have a station in Svalbard called Himadri. We have activities currently starting from this July. Actually, the expedition happening between the Iceland and the Greenland, what we call as the East Greenland Sea. Slowly, we want to expand our oceanographic research activities in the Arctic, and some activities going on in the Canadian High Arctic, and some potential possibilities on Greenland, and so on. All this is originates from a place called Goa. That's the National Center for Polar and Ocean Research. We have also the Southern Ocean, which is currently one expedition going on to the southern part of this Indian Ocean, where especially we focus on the southern part of the Indian Ocean, where our ultimate aim is to understand, because Southern Ocean is an ocean where actually nearly 40% of the man-made carbon dioxide being absorbed, being the coldest and windiest place on Earth. It has exchanged so much of carbon dioxide with the atmosphere, and therefore any changes to Southern Ocean or its circulation or its processes or its sea ice is going to have enormous impact on the climate itself. Because currently, although the warming is related to the greenhouse gases are quite on the high side, but if Southern Ocean also stop working, I think it's going to be extremely hazardous. Also, I forgot to mention that Indian Arctic expeditions or activities have been relatively new compared to that of Antarctic expeditions. That's been almost about 15 to 18 years old now. So this is a place what we call actually NCPR, situated in Goa, overlooking Arabian Sea, beautiful view from our campus, and we manage this many stations, 2 in Antarctica. Maitri is nearly about more than 35 years old now, and Bharati is about it's about almost 15 years now, or slightly less than that. And Himadri station is basically it's a kind of leased space place from Norway. And we also, as I mentioned, third pole being so important for our global health, we also have research activities happening in the Himalayas, especially in the Himachal Pradesh and Arunachal Pradesh, and also partly in Ladakh. So this is in a nutshell actually our various activities. If you look at the science itself, so the all focus of the entire research activities at NCPR are climate change and its impact, and it's what is happening to the various components of the Earth system, including the atmosphere, the biological system, the cryosphere, the Earth systems, and the environment science. And of course, there are very questions which are related to the curiosity of a man, want to know actually how things are going to be different, or how things have been different in the past, and so on. So, as I mentioned, the Southern Ocean is one of various important research activities where our major objective is to look at the role and response of Southern Oceans to the global and the regional climatic variability, with focus on the Indian Ocean. So, the next few slides, I just try to give you a brief about actually what's happening, going on in the polar regions, and what are its global and its regional impacts. If you look at the current, the warming, it is highly non-uniform, of which the polar regions, especially the Arctic region, is warming faster and stronger than the rest of the Earth, where in some part of the Arctic is warming as high as 7 times of the global average, and on an average about 3 to 4 times than the global average. So you can make out there's a quite enormous difference compared to that of the rest of the world. And then another important area which is warming is actually the West Antarctica and Antarctic Peninsula. So such highly different, variations in what we call actually as a polar amplification. And when it is Arctic, it's called, it's most of the thing is found in Arctic. So therefore, it's also known as Arctic amplification. This started happening since 1980s, where almost every data, every model, everything clearly says that actually that, there have been the Arctic temperature on an average has risen by 4 degrees Celsius over the last 100 years with the localized warmings and so on. Even the Arctic sea ice extent has been declining at an alarming rate, about at least 13% per decade. And Greenland is no better. Its ice sheet has been melting and losing mass at a very alarming rate. So this is something which actually happening. And most important key factors responsible for these variations are actually the ice albedo feedback, which is nothing but actually when ice start melting, ice being a completely reflective white surface, when it start melting, it start absorbing, because the water being, about 90% can get absorbed in water, whereas 80% get reflected when it's in ice. So as it start melting, it become more and absorbing more and more black body and start absorbing more and more. And that's become a kind of a feedback system and chain reactions. Then, of course, there are various other factors related to Arctic. Why it is coming? Because Arctic is being so stable atmosphere compared to that of very dynamic atmospheric system we have in the tropics, where convection and other things are very common. There is absolutely no convection or vertical mixing happening in the Arctic, so it's very stratified, layers, which also lead to whatever happens in the surface remains there. And then there is water vapor feedback and so on. As a result, if you look at from the satellite era to the current stage, till if you take that satellite time period till 2000 as an average, it's double, more than 50% has been reduced since then. And sea ice in Arctic has been shrinking in all season and most dramatically during the summertime. That same situation in Greenland, where a large part of Greenland is to be lost, and that the kind of the melting is much faster in the current last decade, and we expect that to be even faster in the next decade. Almost more than about 1,000 gigaton of ice is being already lost during since 1985. Antarctica is no better. Especially the West Antarctica, there are two of the major glaciers like this, the Dwight Glacier as well as the Pine Island Glacier, which are considered to be going to be on a threshold system in future, when the loss of that can lead to the entire loss of the Western Antarctic ice sheet, because all these are actually act like a kind of a belt, and any loss of these ice shelves or even glaciers can ultimately lead to a larger, the loss of ice to the ocean. So some of the new things, development which happens in polar regions, which was not so common in the past, is something like, for example, is an atmospheric river, for example. Atmospheric rivers are nothing but like on land, we have these rivers, which, you have water flowing all the way from mountains till it reaches the ocean. In the atmosphere, we have it's a kind of an extreme weather which transport large amount of heat and moisture, which can be thousands of kilometers long and about 500 kilometers wide. And it can start from the subtropics to reach to the polar regions, both Antarctic and Arctic. For example, just very recently in 2022 March 18, there have been a dramatic increase in temperature at one particular station by about 38 degrees Celsius increase. At the time when it should have been about minus 60 degrees, it reached to about minus 11 degrees Celsius. Such large changes are going to have a significant impact on how the health of these glaciers. So one of the study of my student, actually the Simon clearly shows that actually most of this the extreme weather events which happens in Antarctica are directly related to the atmospheric rivers. And these are also, some studies also clearly show that nearly 60% of the ice loss from the Antarctic Peninsula during the 2000 to 2020, that 2 decades, have been triggered by atmospheric rivers. So under a future warming scenario, we expect that an increased frequency of atmospheric river events, which could ultimately increase the loss of ice shelf disintegration. This is something actually we are, waking up to the, realities. So how is this polar regions now polar regions being so remote from a tropical country like India, they are being completely, out of our normal day-to-day life. But however, it's also important to note that whatever happens there indeed impact us. First and foremost, of course, the melting ice, which also means less reflected heat, meaning more intense heat waves world over. But it also means actually more extreme winters as the polar jet streams start destabilized by the warm air, start meandering south, bringing bitter cold to the south as the warm air to the north. This is something happening for the year after year in the last few years. You must be hearing like US is getting cold waves, and even the regions like unknown to have this cold weather is we are getting that, and Arctic is getting warm airs. Rising sea level is of course one of the most important factor which we have been discussing for several years. But also you should also understand actually as the thermal expansion also happens, there is also an exacerbating activities related to storm surges, coastal flooding, and so on. Most importantly, in a globalized world, the food security going to be extremely in a precipice because of this particular lack of stability of the global climate system. You have an increased heat waves or cold waves, an unpredictability of weather, which can cause serious damage to various crops, which ultimately we all depend on. An increased shipping, although it can happen actually, be increased, the what you call business. But all those new shipping routes are kind of opening up in Arctic will also be the most dangerous ones because they are incredibly unknown, potentially environmental hazards in waiting. And loss of wildlife is of course something which we all will agree to it. And a thawing permafrost is going to be not only in Arctic but also even in the third pole, which store large amounts of methane, which is a greenhouse gas again, which contribute to the climate change. And it's not only related to the loss of the increased contribution of greenhouse gases, but also if you look at the increased thawing also lead to large amount of hazards as we can see in Himalayas, landslides related to things like the Gulf and something. All these are connected systems. So in a nutshell, actually, this is how it looked like. Actually, what happens in those polar regions, how it's going to impact of all of us. We will have more droughts. We will have more increasing wildfires, and the increased warmer oceans can also make the things different and completely disastrous for the whole globe. So what happens in the poles does not stay there, and it's going to impact us in a much than ever in coming decades. If you look at some of the activities and some of the frontiers which we work on, I thought actually I just would want to give a very glimpse of those things because I've already reached I think the 30 minutes limit. I should be taking another 5 minutes to the max 10 minutes. I hope I don't. So if you look at the polar science, there are umpteen opportunities because polar regions offer unique natural laboratories which are remote and pristine. They also happen to be an ideal place to study global climate change, sea level changes, and also to understand the unique ecosystems in our life in extreme conditions, and understand the teleconnections between poles and tropics. Because we know that by now we know that actually we don't understand much of the climate, the weather systems, because it also has dependency on so many other factors. So understanding poles will help us to understand the tropical climate in a better way. However, there are umpteen challenges because it's one of the most expensive research anywhere because it's a logistically very challenging place. One also need to give a long-term support to continue to do such kind of research. We got harsh and complex weather system which gives a very narrow and unpredictable window of weather windows, which means many of the research activities you plan probably will not be conducted during one particular season. Therefore, it's becoming extremely challenging. Most of the time, we keep telling this actually logistic support will decide the scientific outcome. So there are a lot of planning, at least 1 year in advance planning is required if you want to carry out research activities, unlike what we do in the mainland. And the remoteness make it very complex. And on top of that, actually the ongoing global unrest actually makes it more expensive because all supplies and resources required for those regions come globally. And already we are facing increase in expense by about nearly 30% of our normal expenses for Antarctic research. So I give a brief idea about actually some of the research activities we carry out. One of the most important research which we initiated at INQUA from the very beginning is understanding Antarctic climate using ice cores. So this, basically we focus on shallow ice cores below 200 meter, but we also have an interest to, in future to undertake deep ice coring activities. Our main aim is to understand the linkages between polar climate and extratropical as well as the tropical climate system, because ultimately as we move into a warming climate scenario, we want to understand those thresholds and those things which happened in the near past, how it's going to be impacting in future. Some of the most important climate factors, those global as well as regional modes of some of the climate system impacting Antarctica are: one is the ubiquitously very well known El Nino Southern Oscillation, which affects entire globe. And then you are very specific to Antarctica, what we call as Southern Annular Mode, which is basically nothing but the difference between zonal pressure difference between the 40 degrees south as well as the 65 degrees south. As the Southern Annular Mode of SAM, we call it, as it start moving closer to Antarctica, this wind belt start again moving closer to Antarctica. It essentially controls the westerly wind system. Then you have this El Nino Southern Oscillation, which can impact in various, it's in colors and shades. And it's longer, term, 20 to 30 years, what we call as a long-lived ENSO, nothing but it's a Pacific Decadal Oscillation. These are the very common things we typically find in which is impacting Antarctic climate, and we look into those activities what are in ice core records. And the ice cores which we work on typically are the very highest possible resolution in the coastal Antarctica, where the accumulation of snow is very high. Therefore, you can actually get a seasonal to annual scale sampling and dating. So we see that as the globe is been warming since the industrial era, we find a significant shift towards increasing El Nino Southern Oscillations and decreasing long-term climatic variabilities, long-term cycles. So this is something actually we are going to expect as more and more the globe is warming. We will have more and more impact of El Nino ENSO impact in Antarctica, especially which I'm focusing on this particular part of the Antarctica where India has been mostly active, the Trolling Moorland region, where we can be very clearly in the modern times actually this whenever the ENSO in what you call the El Nino or in La Nina time, they keep changing accordingly in Antarctica also. So we see that actually these particular possibilities in future. And another important factor, which another finding we made actually that Antarctica being a land without any dust, most of the Antarctica is covered by 98% by I don't know, there's something wrong is happening. It's okay. This I think by mistake. I don't know. Okay. Anyway, leave it. So what did we found actually is that the annual resolution of our ice core records very clearly shows that. Aparna, are you drawing something on it? Leave it. So we find there is a dramatic increase in dust to Antarctica since 1980s, especially the late 20th century, which is directly related to what is happening in the Patagonian desert in the southern South America. Because the only dust source to Antarctica is from the southern hemisphere lands, and looking at the wind pattern, it's mostly from the southern South America, where you have this Patagonian desert is there. There's a significant increase in dust since late 20th century to Antarctica, which also is contributing to radiative forcing, which our studies show that nearly about 30% increase in warming due to aerosol forcing. So this is something again very interesting. Someone has drawn something on the screen there. Can you please remove that? I can keep seeing that. Maybe Aparna, it's from your side. I saw your name in between. Okay.
No, sir, I have not drawn anything.
Some blue lines. It just I saw your name, then you start something going around here.
Sorry. Hey, Aritina?
Yeah, these
Aritika?
lines which I can
Yes,
see.
I'm here, but I can't do anything. I'm just trying to figure out where is the problem.
Okay.
Can we
But
stop
maybe there is someone with the
people making
pin.
the mark?
Okay, doesn't matter. It's from someone else. It's not from me because I have only one pointer. As you can see, that's keep moving. So therefore, it's not from my side.
Okay.
So
Yeah,
I
no,
can.
sorry, it's not from your side.
Yeah, it's someone. Some kids are there with near their parents, probably drawing it. No problem. So the another study which we a recent study we show that actually that we try to reconstruct sea ice using ice cores. We find a significant increase in sea ice during the recent time periods, and then there is a dramatic decrease somewhere around 2060s. And these are again found to be related to the changes in El Nino system as well as the SAM. And this is going to be actually, again, very important to understand as we, the climate is warming in future. So there's also a rapid warming happening over East Antarctica, especially some of the coastal East Antarctica, which is again connected to this the tropical influence, that is the El Nino Southern Oscillation. So we can find that there's a clear linkages between poles and tropics. Although these polar regions appears to be so remote from the tropical countries, the studies have shown that the climate changes in the tropical and polar regions are interconnected. And also some of the substantial Arctic warming also may be driven remotely from the tropics. And some of the changes what we see in Arctic, especially the sea ice loss, could lead to increased tropical sea surface temperature, increased precipitation in the tropics, and a shift in position of intertropical convergence zones, so on, because it's directly get connected to El Nino Southern Oscillation and so on. The warming Arctic is essentially driving extreme weather. As I just mentioned some time back, actually, normally there's a very stable polar vortex around the Arctic and Antarctic, which helps the cold air remains within that. And this strong jet stream is the one which traps it. So you have the anticyclonic, anti-clockwise jet stream happening, which actually controls this entire polar vortex. But as Arctic is warming faster than lower latitudes, what is happening is that actually jet stream and polar vortex start weakening, which allows Arctic air start moving south and warm air from the south to move north. So that's becoming a wobbling of this meandering of this polar vortex, which essentially impact the whole global climate. And there are studies show that the teleconnections between the tropics and Arctic is a two-way street system, where you also have whatever happens in the tropics, especially during an extreme rainfall events, which generate large amount of latent heat, can travel all the way to Arctic. And then sometimes what happens in the Arctic due to the high pressure, low pressure systems can also reach to the tropical systems. So if you, due to any changes, this jet stream, what we see actually in the northern hemisphere is getting affected. We see that there is an excitement of this Eurasian wave train, we call as the Rossby wave train, which affects the upper atmospheric monsoons circulation, eventually the rainfall itself. This is one of our study again from our NCPR actually, which show that there's the potential relationship between the Arctic sea ice loss and a late season Indian summer monsoon rainfall, extremes especially. So they find an increased extreme rainfall events in central India does coincide with episodes of reduced sea ice in Arctic. And they also found with a mechanism which is proposed as where upper atmospheric divergence created during that particular sea ice loss ultimately reach subtropical Asia by atmospheric waves, which is the planetary waves like Rossby waves. Another study from NCPR shows that an intensification of Arabian Sea cyclone, which we see very clearly of late, has a direct relation to a warm Arctic. And some of the studies also shows that from some of my colleagues that the Arctic climate and Indian summer monsoon have a direct, very significant teleconnections even during in the past. When within 1,000 years time period, looking at the last millennium, where they find warm Arctic intervals are directly associated with higher Indian summer monsoon precipitation. And we look in deep in time, further much deeper in time, like time period like mid-Pliocene warm period, which is considered to be the analog for the current increase in carbon dioxide where it has reached to 420 ppm and going faster. So that was a time period when we have this mid-Pliocene warm period about 3 million years back. We find that a clear lower sea ice Arctic, which is a warmer Arctic, losing sea ice in Arctic means the warmer Arctic, lead to a stronger South Asian monsoon during that period. So there is all this kind of studies clearly shows that there is a clear link between what happens in the Arctic and in what happens in India. Through different time scales, from a interseasonal to interannual to decadal to the millennial to and longer time scales. So all this we do carry out at the NCPR. We have various research facilities. We have an opportunity to visit. I would say that you should take use of it. And this is one of the old picture. We have the facility has been expanded of late very exponentially. The various potentially research facilities and activities happens here. If you have an opportunity to come to Goa, I think you should make a visit. And we also have a large increase in the polar women of late in the coming to the Antarctic and Arctic expeditions, because unlike in the past, now it's becoming the women are actually really in the front line of various research activities at NCPR now. So that's something actually I just want to point out to some of the young researchers who are sitting over there. So that's all. I just leave it there actually, and we just want to say that actually do try to collaborate with NCPR, try to carry out research related to polar regions, look at new frontiers where you can make a difference, new research contributions and so on. Thank you so much.